One yes. Okay. So I think until 6 or until you're tired of me, I'm just going to be live coding. We'll see how that works. Again, I have a MacBook Air in front of me, and it's it's not that bad actually. This MacBook Air kicks the ass of my MacBook Pro with the Intel. So, we'll see how it goes. As I mentioned, there's some things I already want to show you, so I'll maybe start with that. But I'll be working from this from the exact same starting repo that you guys work with, and then I'll be sharing either through Zip or Git if I can figure it out these things with you, right? Obviously, everything I code is gonna have big asterisks on it. So listen very carefully here, right? Just because I code something here doesn't mean that that's the right code. I'm coding here things that work, things that express ideas. But it may not be that this is the right thing for your scenario. What's a good example of that? I might, for example, create if you're asking me about proposals or voting, whatever, I might create some struct with some fields in it and some whatever, and just show you, this is how you make a storage map. This is how you make some fields, whatever. It could be that my storage fields are very inefficient, right? That you shouldn't just copy my idea of a proposal and say this is the one I'm going to use, right? I'm just going to show you quick and easy things here. You might have to actually add more complexity to those items, right? So what I'm showing you here is just working code which expresses ideas, right? It's not the answer to solutions, right? That makes sense? Okay. I think that these are all good starting points, so I'm just going to go through them. And then if you have something you want me to program, maybe you make a note to yourself, and then raise your hand if it's relevant or whatever, all that kind of stuff. Let's start with the balances and assets, okay? Because everyone's going to be doing something like that, right? All right. Can you guys see my screen? This is a decent size. Okay. So let's go into the DEX palette. Okay, so you can see here the DEX palette already has implemented in it the native balance and fungibles balance. And if I do cargo test p palette DEX, it should compile and pass. So the way I'm going to be doing some coding, at least to initially show how balances behave, is by writing some tests, which just use these APIs and then sees what happens. Okay. So let me just make sure that the tests compile. It does? Okay, that's good. So there's some stuff here. So what I can do is I can just create a new test. I'm copying here. By the way, when you work with tests, I know we haven't gone over tests more in depth yet, but make sure you always include this new test externalities, this thing, right? So I'm always doing tests within this thing. This gives you access to a virtual database, like a virtual substrate database. If you try to do things without this, it'll say there is no database. Something like that, right? Okay? So let's try to do some stuff. So I'm gonna, again, I don't remember all the things off the top of my head. Let's go lib. Put this here. So there is native balance and fungibles. So there should be a way for me to access these traits. If I do test as native balance, : total issuance, I should be able to get, let's see, assert equal this and 0. Let's see if this compiles. Let's see, basic balance stuff. Not found in scope. Native balance. Test as, maybe test as config native balance. Oh, like this. Test as config. Sorry, this is the real life coding, man. This is real life. And once I get good code working for you, then it'll be good. Here, let's see what's happening here. So which configs? Let's do create config. Create config. again, I think when Keon was talking about the fully qualified syntax, you're seeing now here what happened. Well, finally got it working, right? I started with this native balance. Where is that trait coming from? It's coming from config. Then I did it. Russ was like, which config? My config. Create config, has native balance, and it compiles and it passes. So here, you can see the total issuance of my blockchain is 0. I haven't done anything yet. So let's mint some balance. Assert, OK. And I can maybe even make a helper here. Maybe I can do like let or type. Let's do type native balance equals this. I think that will work. And then if I do native balance, expected one of type native balance. One too many, yeah, angle brackets. Thank you. Great, that's way better, right? I think everyone was happy about that. Assert, OK, native balance. Let's look at the API. I think there's probably a function called mint, but let me look again. I don't remember everything off the top of my head, so I'm gonna go into the balances palette, substrate, frame, balances, source, implement fungible. Somewhere here there should be like fn mint, fn set balance. That sounds good. We set balance on hold. Maybe fn set balance. Nope. Where's mutate? Can withdraw, reducible balance. So these are all the queries here. Can withdraw, handle dust, write balance. That could be one. Wait, this is okay. So real quick, this is actually not the best place to look. Let me actually do something. I don't do this myself a lot, but I should do it. Parity Tech. We just look at the Rust docs. This is much better for this kind of thing, right? It is Polkadot SDK. Okay, thank you. All right, let's go to fungibles mutate. Is that there? Yeah. Tokens fungible mutate. So here's the trait. There should be a mint into. So there's a function called mint into, which is what I want to access. So the reason why it's better to go from this trait is that inside of the impl, I think there is not mint into. Mint into? Yeah. Thank you. Yes. Fungible. Fungible mutate. Thank you. There's still mint into. But I think if I look at this code, the reason why it doesn't exist here is that probably this function has a default implementation using other functions. So if I went and looked at the source code here, what's the easiest way to look at the source? Let me find this fn mint into this support fungibles. You can see here, look, the mint into the function exists in the trait. But I don't see that balances implements it because balances implements it using other functions. So it's a default implementation in there. Does that make sense what I'm saying? That you're not going to find the implementation inside of the balances palette because we don't need to write the code for it. The code is already defined in this trait. So it's better to look at the trait actually for that stuff, okay? But anyway, mint into. So let's use that real quick. So we're here, native balance, mint into. And then in this case, we can do like let Alice equal 0. So I think in this test environment, all the accounts are just numbers, right? And we can define that in our mock, right? So in the mock, account ID is U64, right? This is the power of generics, right? In a real account, you have this big, long account ID. But I want account 0 sends to account 1 or whatever I want. You know, you could do that. You could maybe even here do like static string, right? But, you know, U64 is easy, right? So in this context, Alice is account 0. Let Bob be account 1. And so mint into Alice. And what is the API for mint into? Oh, this is the wrong one. This is the, where's fungible? Mint into fungible. Mint into who and amount. That seems easy enough. We mint into Alice and we give her 100 tokens, right? So then I should be able to call total issuance is 100, and I should be able to call the balance of Alice is 100. And I should be able to say the balance of Bob is 0. Let's leave it 100. I'll let it error to me, okay? So please, everyone, cargo plus nightly format. Cargo plus nightly format. Makes that much nice. And then let's test. I should get an error. Okay, let's see what else. So free balance. Okay, free balance. I think there's probably also total balance. I can do that better. Total balance. Or I can do free balance here. Let's see, free balance here, and then total balance here. And obviously, free balance is the transferable, like the not exactly transferable, but like the free balance, and then total balance includes things like reserves, right? Okay, total issuance. Is there not total balance? It says I need to include some traits, so maybe I have to do. Bob is 0. I know. I want the test to fail, but I think I just need to use a use. I need to do use SP. Wait. Use frame support traits fungible star.
Without the S?
Yeah. Thank you. Okay, almost there. I think that these functions are expecting a reference rather than the direct account. Why don't I have, speak up, sorry? What's cargo on the fly? Oh, Rust Analyzer. Well, one, I have a MacBook Air right now. I mean, you want my MacBook to die? Like it's it's the only one I got left. But actually, I truthfully don't use Rust Analyzer. When I started programming in Substrates, it wasn't good enough, and I never found that it has provided to me what I can't do already. So again, for some of you, like I also, you don't see, I don't use GitHub Copilot. I'm maybe I'm an old man in the Substrate world, but the way I work, I mean, it works for me. Like I just, I don't know how to say it. Exactly. I never used Vim or anything like that. Yeah. Anyway, so this is failing, but that's good, right? 0 or 100, right? So if I change this Bob to 0, I'll have a passing test. Bam. So this is already useful. We're already starting to see how we can use the APIs. This exact same code could work inside of the actual palette, but we're just doing this right now inside of our system. Let's actually, I can even do quickly here. I can make a quick new call, right? Let's do a call, palette call. So I can just copy this real quick. So this is a new call.
So everything is ready, you just need to write this.
No, not at all, right? Yeah. Yeah, exactly. Thank you. Yeah. This. So here, let's do this. Let's do like give me money. Okay? It has an origin, dispatch result. There's a who, and whoever calls this function, we're gonna mint the money. So in this context, we have the native balance from here, but it's attached to T, or T config, right? So what we call this is T native balance mint into who, which is the caller of this function, and let's give them 69, 420 tokens. Okay? Is that going to work? Okay, and then we have to return OK, right? The function works no problem. Okay, so let's now recompile this code. I mean the test, obviously. Close the search box. Yep, and I'll close this too. I'm not using this right now. I guess that's funny. It's so funny. Rust wants me to import this thing again, even though it exists up here. So I have to import it. Yes, Rust. Thank you for your looks. Okay. So use fungibles, star self. Okay, and I need to borrow. Thank you, Rust. Let's go here. Oh, I can't do this. Why can't I do that? Because the balance type is unknown, right? Ooh, I made the mistake. I can do this though. U32.into. Let, okay, it wants, oh, this returns some function, so then this should be a question mark operator. So it can propagate up an error if there's a problem. Awesome, done. Latest. I can cargo version 1.75 from 1120. Is that okay? Okay. But great. Look at this. I have a brand new extrinsic in my blockchain. Give me money. You call it, you get money. This is the power of runtime development. You all can have whatever amount of money you want if you build a blockchain that does this. We talked about meme blockchains. This seems pretty meme to me, okay? But this is the basic example, right? You can imagine that instead of just give me money, there's a process, let's say, hey, authorized account gets money, right? So we can change this from ensure sign to who, T, account ID. And then this would become ensure root. Now you have a permission function. Only the root can give money and chooses who to give it to. Right? Very fast, very simple, very easy. Anyway, so this is showing basic examples of using this API, right? That's the main idea here. Is I want to just show you that there is this associated type native balance. This associated type has all these traits. You're able to access these functions and use them inside of your runtime. Now, one thing I want to mention. So this is a little bit of a trick. I don't necessarily recommend it actually, but it can work for the short term. As I mentioned, we do not know the balance type. We can't just put a number. It will say we don't know. But the balance type, one of its traits is that it is at least U32. So any U32 can be converted to a balance type because balance type must always be bigger than it. So in this case, we're kind of bypassing the type thing. We don't know if it's U28, we don't know if it's U64, whatever, but at least has to be U32. The better thing here would actually be something like this. To use the balance type itself. So balance of, we need to generate this first. And then 1. It could be a function 1. So we need to generate this balance of lookup. We have that already? Balance of, oh, we do already have this. So I already include in your template a way to access the balance type through all the generic craziness. Okay, so let's take a quick look at this code right here. So what do we know? We know that there is a palette balances, right, which implements some trait fungibles, and in these traits there's a generic balance type. Yes, if we want to access this balance type, for example, I want to create a function, give me money. Let's do another one. Give me, I can do give me specific money. It's an origin and it's an amount. I want some balance type here, right? Some kind of balance going on in this thing, right? So what I've given you access to is this balance of T. And in this context, I can mint that amount. Let's make sure this compiles. Let's get rid of this. Doesn't like it. Runtime origin, dex. Oh, it's because I have two of the, wait, no. The same call index. So there's probably some error up there saying the call index is duplicated. Balance of, what did I do here? Amount balanced. Oh, use crate balance of. Okay, crate. That's weird. I should import all these things. So I should import crate automatically. So I'm going to go into here. I'm going to do use crate. colon colon star. This will pull all of the things from out here into this module context, right? And then I should be able to do without the crate. Okay, so you see this function passes. So now let's explain where this balance of came from, right? So I'm able to create a function and input this, use this single balance of t to define the type of the balance. Again, we don't know if it's U64, U128, whatever. It's just the balance of. So in this context, what are we doing here? So somewhere inside of the trait inspect, there is a type balance. That's the most simple thing. So let's break it down into steps here, okay? Inside of the trait fungible inspect, there is a type balance. I can show you that, right? We can go back to here. Inside of the trait fungible inspect right here, there's a type balance, right? But this inspect trait has a generic parameter, account ID, right? So I need to put here account ID. But where does account ID come from? Account ID comes from frame system config. Remember, account ID is defined in frame system. How do we access frame system config from T? Because our T config inherits from frame system. Following so far? I think I already lost you. Okay, let me just say it one more time the 3 steps I said. By the way, this is a great reason to do the Rust state machine. I'm telling you, if this is the blocker for you, spending a day on Rust state machine is worth it. Okay? There is a balance type on fungible inspect. Fungible inspect requires a generic parameter, account ID. Account ID comes from frame system config. Frame system config comes from our generic config, T. Okay? This much so far. Where does fungible inspect come from? It comes from native balance, right? That fungible inspect is one of the traits native balance supports. And where does native balance come from? It comes from T as config. As. And I think that's basically, we got to the same thing, right? T as T config native balance. This is our associate type from config as the inspect trait with this generic parameter getting the type balance. Now, it would suck if you have to write this every time, which is why we create the alias type, balance of, T. And as long as T is config, it can go down this pipe and get the balance type. So in this context, this entire line is replaced with balance of, and I'm able to access this amount as balance of T. Now, this is different though. Imagine, give me specific money. I can do another function. Give them specific money. I can do who T account ID amount balance of, right? And this is who, and that should all work. Let's double check. Oh, who twice. This one I don't need. Ah, the fucking index. Okay, this works too. So now the reason I wanted to show this was that obviously this one and this one are kind of similar, but the syntax is different, right? One is T colon account ID. One is balance of T. Balance of T again is this alias, right? The alias definition, the way it looks like is like this. It's the balance of T. T account ID is coming from our config directly through frame system. Right? That's why we're changing the way it's referenced. But these patterns again, you can if you understand them, great. If you don't understand them, follow the pattern. So I'm showing you this code here right now. I'll send it to you. You should have now access on how to access balance type and account ID type, right? And use them in your palette. But I want to mention, this is all Rust. And I truthfully believe this is the most, this is the place where newbies stumble. It's just getting over this type stuff, which is why I really believe something like the Rust State Machine forces you to do all this stuff manually. It's a great way to learn how to navigate through this stuff. We had a question there first, and then we can go over here.
In my case, I don't know why the mint into like doesn't exist in my context. I don't know if you added some import.
I added this. I brought in here. I have to import. You have to do use frame support traits fungible fungible star.
Okay.
So it wants you to import the trait, which does it. And I think if you look at the error, it says that. Sure, I can copy and paste this. Yeah, but I think he wants it now. It's okay. This is which one is this? Dex. Nope, that's not. Message.text. Maybe it's too big. Okay, maybe it is. Okay, let me just. Let's see if that works. Okay, you tell me. Oh yeah, it's there. So that's that file. Okay. But that should solve that problem. Or test palette Dex. Okay. So this is working. So that's some basic usage of the API. So now I'll also do the same thing for the native assets, right?
I've got a question here.
Yeah, question. Yeah, please.
So can you get the previous file, the lib?
The previous
The
file?
library? Yeah.
Go to lib. Okay.
Yeah. So in the config, native balance already as a type inherits from fungible inspect with self account ID. So if you go up to the frame system config, yes. So it already implements this. Why do I need to do the balance of and not use the native balance directly in this case?
Because native balance isn't the balance type. Native balance isn't U64. Native balance is a associated type giving you access to APIs. It's like a struct. Native balance isn't a U64 type. Balance of is U64 or like U128 type. This navigating down and getting to this balance type, that is the actual raw number. Native balance is an associated type, which it gives you access to the APIs.
So in the runtime, I configure. When I configure this, I configure the balance of or the native balance because I will need to configure the native balance, right?
Right. So let's just show you that. I'll show you exactly how that works. In the mock, you can see in my palette. Oh, it's called palette. Yeah, palette Dex. The native balance is equal to the balances palette. This is the palette. And in the balances palette, I define where's the balance type? This balance equals balance. And somewhere here, balance equals balance, probably, I have balance U128. So the balance type is coming from the balances palette, which is coming through this type. So again, that native balance type is not this U128, it is the balances palette. And the balances palette is telling you that the balance type is U128.
Thank you.
Yeah. It's okay, guys. I know this is literally the most complex part of this whole generic system. But I think my hope to you is this, is that you understand the potential power of this system. Once you can harness that power, it doesn't become a limitation, it becomes a superpower. Right? And getting over that gap is the hardest part of working with these systems. The way I learn best is truthfully is to attempt to understand as best as possible, and where I don't understand, move on. Just copy and paste. What's beautiful is that the Polkadot SDK is like literally a million lines of working code that you can compile and that you can copy and paste to your heart's content. Somewhere in between your code and this code, there is something wrong. Like if your code isn't working, there's existing code that does work, and you just have to figure out what the differences are. There's a lot of examples. There's Stack Exchange, there is ChatGPT, there is me and the other instructors. We can help you get to that point, okay? Great. So let's quickly, okay, this is what I'm trying to do with live coding. So let's quickly just do some functions with the assets palette, and let's also quickly look at the holds and the freezes real quick, okay? So let me do that in a, I'm gonna share the love. I'm gonna do that in the treasury palette. Sure. Okay? So in the treasury palette, I'm gonna do something that mint asset, pub, function, oh, let's get this stuff, change the call index, pub function, gimme asset. There's going to be an origin. Okay, just copy more stuff. Origin 4. Origin 4t. Asset ID. Asset ID of. Very similar. If we go back up to here, I have a thing that tells you the asset ID of. Okay. Asset ID of and amount, which is asset balance of. Notice I'm using the asset balance, which can be different than the normal balance. This returns a dispatch result. And then I'll do let who equals ensure signed origin. T what's the associated type? It is a fungibles. So T fungibles mint into who, maybe asset ID and amount. Okay. Now I think actually that this will compile, but this will fail, and we'll talk about that. Format. Oh, not Dex. Palette. Treasury. Okay, let's see what the error is. Asset balance of. Oh, it's the same thing. So all of you should add this line. Use crate : star. For whatever reason, it's not there. I think in your template it has it, but okay. I need to also include. Yeah, this is terrible. Use fungibles. No, use frame support traits. Fungibles.
I have a quick question.
Star. Here I'm using fungibles because it's the assets, right? It's multiple assets. What else? So mint into, it didn't like it. Unexpected argument of fungible. So I think I'm not supposed to put that ampersand on this asset ID.
I have a quick question.
Yep.
Is there a difference between using crate star and superstar?
Crate star versus support star.
Superstar.
It's the same thing, I think. I mean, in this context, it's the same thing, right? Because super and crate both point to the same thing.
Yeah.
Yeah, I don't think there's a difference. Yeah, thank you. Asset ID, then who. Yeah, I mean, if I looked at the API, I wouldn't be fumbling around here, but put an ampersand on who. Thank you, Rust.
Sorry?
More questions? Yeah, ask questions. You don't have to wait for me to acknowledge.
The weight in the, where does the weight come from? The weight
Yeah, the
default.
weight right now is default. Again, we'll talk about benchmarking on the last days, but
Not the meaning of it. Where is it imported from?
weight is coming from palette prelude. It's coming like there's these two lines here, like frame system, palette prelude, frame support, palette prelude. It's importing a bunch of the common types and structs and things. So like all of that's coming magically through there. Does that answer your question?
Hopefully.
Okay. So this compiled, this worked, right? Let's actually do a test, right? So this compiled, this worked. Let's make a test. Test, and I think this will fail. fn mint asset works. We're going to copy this. We're going to do something. Okay, so we're going to call our extrinsic. So we're going to do like let Alice equals 0. We're going to call our extrinsic, which is going to be fungibles mint into gimme asset. Okay. And my item is called deck. Ooh, I made a mistake. When I was copying and pasting these things, you can see the palette treasury, I imported it as palette dex. So something to fix. So I see I have use crate here as palette dex. Sorry guys. Palette treasury. This is just fast. So this should be called palette treasury. Should be palette treasury. You see, the naming is just naming, right? It's not a big deal, but do you see what happened here? Okay, sorry. So you can fix that, or if I fix it throughout this, you can copy and paste my code. Yeah, I mean it works without the renaming because I named everything Dex and it works, but here I want to call it treasury. So I call treasury, call mint asset, right? In the treasury I have a gimme asset. Gimme asset. It is asset ID. Let's say this. Let's do let asset ID equal 1337. Let amount equals 420. So we do gimme asset ID amount. So raw origin signed Alice asset ID amount, and this should be assert OK. Assert OK. Let's start with this. Let's just see if this compiles. Okay, so here, Dex. Replace that with treasury. That's the thing. That the palette Dex is like I copy and paste the Dex to make the treasury, and so I named. So in the mock, you need to rename Dex to treasury. You see? What did I change? I changed 3 things, and I apologize. This is my fault. Here, inside of the mock, I said use crate as palette Dex. This is the first mistake. This is the first. I named my crate and I named it palette Dex. It should be called palette treasury. I'm sorry. And then here, palette treasury. And then here, treasury. Right? It's just naming. Palette Dex, palette treasury. Okay, almost there. Raw origin isn't working. Oh, maybe it's just origin. Origin signed. Frame system. Maybe it is raw origin. So this is where I would go look. Let's look at the other examples. Runtime origin. Sorry. So you can see right above they have example here. Runtime origin is what I want to use. Okay. So calling my extrinsic failed. Why? Unknown asset. So there's multiple steps. If you want to give someone an asset, you need to do a few steps. You need to first create the asset, right? That's one piece. So we have to actually go ahead and write some quick logic for that. So let's go ahead and do that. So I think there's going to be a T fungibles create asset. Let me check the API. Let's go into here. Fungibles mutate. Or maybe there's a fungibles create. Probably there's a fungibles create. Let's go to this. Fungibles. There is create here, a trait create, and that creates that. So I need a function create. It has ID, the admin, sufficient, min balance, okay? So let's go back here. Create. the ID of the asset. So that will be the asset ID. The admin of the account. Okay, I'll make you the admin. Whatever. That's just something to fill in. Probably you want to like generate some admin account or something. I don't know. That's you have to think about that. Is sufficient. So let's briefly explain what is sufficient means. Is sufficient. You probably just in general set it to true for you all. But what it means is if an asset is sufficient, it means that you do not need to own the native asset to own this asset. So normally, with a non-sufficient asset, you need to have at least one dot to own the token. But if an asset is sufficient, you can own this token without having any dot, right? So this is also something configurable, but for the sake of your stuff, you can just put it to true, right? For example, in Polkadot, USDC is a sufficient asset. You can own USDC without owning dot on Polkadot. But Bitcoin is not a sufficient asset. You must own dot to own Bitcoin. Okay? And then the last one is minimum balance. So this is like the existential deposit. So minimum balance, let's say that's equal to asset balance of T1. You must have at least one of the asset. Okay, let's see. And this also has a question mark. This could return an error. Let's see if this compiles. Nope. I need to import the trait 1. Thank you, Rust. That actually does feel a little bit bad, right? Like it knows what needs to happen. Come on, man, just do it. You know what? One thing I liked about Go, I didn't do that much Go, but one thing I liked about Go is that it really, like while I was writing code, it was importing things like crazy for me. Asset ID moved, so I need to clone it. Who moves? I need to clone it. There we, wow, it compiled. And the test passed. So in this case, the difference, right, was I tried to mint some asset into a person, right? But the asset wasn't created. So in this context, I need to create the asset, then mint it, okay? Now, I wonder if I put false here as sufficient, what would happen? Now, it again fails again. It says, I cannot create the token because this is not sufficient and this user doesn't have any balance. So how can I solve this error? I can actually go and do T currency, no, T native balance, mint into, and I can give who, let's do like, I mean, yes, I don't know, 69, 69, 69, 69, u32.into. Again, this is not the perfect thing, but I'm just trying to show you examples. And I think this will work now. So I need to use mutate. Thank you, Rust. Fungible. Mint into. Fungible. Fungibles. Wait, what? That's crazy, right? Because it didn't need that before, but doing this. Oh, maybe because it can't determine the difference between these two. Ah, shit. You know what it wants me to do? Yeah, it wants me to be more specific. Because right now I have two different traits, which both have the mint into function. Rust, you're a mean person. Okay, so T. So T native balance as fungible mutate. That looks a little bit weird to me, but let's see what it says. Expected one generic argument. Maybe I can do underscore so I can avoid having to tell you what the generic argument is. Mint into, okay, so it wants it for this one too. T fungibles as fungibles mutate, or yeah, mutate underscore. let equals. I need to put a question mark. By the way, don't do the underscore equals. You should just do a question mark, right? Because when you do underscore equals, you're capturing the error and not propagating it up, right? You need to do the question mark. So that suggestion it told you is bad. Did it compile? Oh my god, yes, right? And so, okay, this again, I'm sharing all this code, and hopefully you're following along with the process. But again, I want to show here. If I don't have this line where I mint native balance to the user, and I try to create an asset and mint it into the user, it doesn't work because this asset is not sufficient. Two solutions. One solution is make the asset sufficient. Then the test pass. Or don't make the asset sufficient, but make sure that the user has an ED. Okay, so let me write this, okay? If the asset is not sufficient, you need to make sure the user has ED. Or here, you can set false to true, and a sufficient asset does not need ED. But again, the idea is that you have to kind of design your system, you have to play with these APIs, but I want to show you that these are the basic way to access these APIs, write tests, etc., right? So this is one other thing. So any questions? Yeah, let's go.
Yes. I have a Rust question.
Okay.
There you imported the triad1 to enable use of asset balance T1.
I imported what?
At the row number 1, yes.
Oh, row number 1.
Yeah.
This number
Sorry,
1?
not here. Sorry, I was not complete. You used asset balance 1 to generate one value of asset. At the last.
Okay.
Last.
So here, this I use
Little
asset
bit
balance
up.
of T.
No, not that. A little bit up.
Up or down?
Please scroll. Yeah, this one. So at the row number 151.
151.
Yeah,
Okay.
and at last, asset balance of
Oh,
T.
yeah, T1.
So this one started to work as soon you imported the trait1.
I had to import the trait 1.
Trait1. But trait is usually implemented on any type. So I have seen at other places also, you just have to import the trait and it automatically implements on a type.
No, it doesn't automatically implement. I just know that this type implements 1.
This type implements 1.
So it was implemented somewhere else. Importing the trait doesn't implement it on all the types. This type already is forced to implement 1 because it's a number. That asset balance is a number. Inherently, numbers have the number 0, have the number 1.
Yeah. So then, if it already implements 1, then why do I have to import the trait1? I mean,
Because
that kind of question, yeah.
again, Rust wants you to be explicit about which trait you're using.
Okay.
Right? So it could be that there's some other trait that also has a function called 1, and it can't guess which one you want, right? So when you import the trait, it worked. And also, this is why I had to do this. I had 2 traits which had the function mint into. As soon as I added the other one, it said the first one no longer works. So when I didn't have this line of code, I was able to write this without the full expansion because there was only one trait that it could work. But as soon as I added the other one, then 2 traits came into play. It said, hey, I don't know what's going on. You have to be explicit. So this is really why Kian went over in his lecture. This the fully qualified syntax, is what you need to do. So Rust can try to cheat for you, but as soon as it even thinks there's a problem, you have to do the fully qualified syntax.
Okay. Yeah. Thank you.
Okay. Can I? Yeah. So how about I can show you import for 1. What I can do is I can take this function, I can put it into Dex, but I can only just do 1 asset. Okay. So I won't do this one. Yeah, but I'll show you. Here, this, and then this, and then none of this is needed. And this should be true. Palette, Dex. I need to include fungibles mutate. That's fine. I think this is the answer. This is. What's the best way to do this? I'm importing both of these things. I also need this one too. Give me 1 second. So what do I want to do? I want to do this. Let's try to do more explicit. Use frame support traits fungibles mutate. Let's see if this solves it. Create. I need to use create as well. Native balance. Oh, did I do the wrong one? Shit. No, it's because both of these are in here anyway. Yeah, I can't. What is it you want me to do? You want me to? You want to see the use statement? Yeah, the use statement is like this. Yeah, frame support. Sorry, let me just delete. This is just gonna cause more problems. I wanted to try to show something, but yeah, it's not gonna work easy. Palette dex is being compiled, so you don't need trait 1. Okay, and we go back to treasury. And then in treasury, okay. Okay. Anyway, sorry. I mean, I try to get some examples there, but I think it's not going to be more simple. So this is a working of this asset thing. We have a test which calls our function. It gives the asset to the person. We can maybe verify they have the asset. Assert equal. We have to do the alias thing. Type assets equals test as fungibles colon. Wait, what was the logic? It was native balance. Oh yeah, test as crate config fungibles. So that's a lookup for that fungibles, and I can do assets balance. Let me see. Free balance of asset ID Alice should be equal to amount, right? Free balance. Is there no free balance? I guess just call balance. Okay, it's balance. Okay, it's called balance in the assets. But you can see here, it works. Right, so this minted that balance. Okay. Okay, so that's assets. So let me go back to my to-do list. I'm not losing you guys, right? It's helpful. Okay, great. Okay. Dex and treasury, we showed how to do basic interaction balance and assets API, right? And if you are struggling with some future ones, we go to I wanted to do freeze and hold, right? Okay, let's do that real quick. I can just do that in a test by itself. Okay. So remember there were some weird behaviors about the freeze and hold stuff, right? So test fn freeze and hold works. We can do this. Okay. And then, okay, so we're going to mint some balance for Alice. I think I have some code for that already, right? This code, I can copy this. Mock tests. Okay, so Alice is 0. Bob, we only need Alice. Mint into Alice. Okay, 100 tokens. This is all fine. Okay, so now let's freeze some of Alice balances. Okay, so assert. Okay. Native balance. Freeze. Alice. 100. Let's. Did that work? Let's actually look at the APIs here. So in here, I'm looking at tokens, fungible, individual, freeze consideration, modules freeze. Wait, this is structs, traits. Traits, inspect freeze, mutate freeze is what I want. Set freeze. So I can set freeze with an ID. Oh, God. And who and amount. Okay. So this is good. We're learning stuff here. Let me check what the ID of the freeze IDs are set to. I think that this is gonna be okay. Nope, wrong one. Sorry. Here, okay, so it goes to the mock freeze ID. Freezer. No, palette assets here. This one. Freeze identifier is the null. Okay. I'm gonna just make this work, and then we're gonna talk about it, and we're gonna see how we can do this. So I'm gonna do set freeze. That was the API, right? Set freeze with an ID. The ID is gonna be ampersand null. Who to Alice. I'm gonna set the freeze to 50. Let's just see that this works. Palette treasury, right? Yeah. Undeclared use of native balance. Okay, I need to copy this thing from tests. Tests here. Okay. Cargo test, please work. Bam, it worked. Okay. And then we can look. So set freeze here worked, okay? Another thing that I think will work is set freeze, as I mentioned to you, 5,000, right? It can be much more than the balance of the user. It also works, right? Now let's try some basic things here. So let's do set freeze 50. We can do assert, okay, native balance, transfer. I guess we do need Bob. Let Bob equal 0. Or I can just do this, transferable balance, right? There should be transferable balance of Alice. In this context should be 50, right? Usable balance. Okay, let's try usable balance. Or maybe reducible, right? Reducible balance. That's the transferable. Reducible balance of Alice should be 50. Expected U128, found integer. Or result. Assert okay. Oh, assert equal, sorry. Assert equal. Reducible balance, preservation and fortitude. Ooh, is that what I want to do? Let's look at the API here. Fungible, inspect, total issuance, minimum total balance, reducible balance, this here. So I want to do preservation and fortitude. So this is telling me like I have to pass into it like what kind of thing. This is a little bit annoying. Okay, let's do expendable. So preservation expendable. Preservation expendable. And fortitude. Polite, I guess. Yeah. Yeah, I mean, there's a million ways you could do this. I mean, you have to probably do the same API for withdraw. Like, it can withdraw. Oh, okay, thank you. You're right. Thank you so much. That is much better. Thank you. Can withdraw. Thank you so much. That is much better. So it should be true. Expected withdrawal consequences. So can withdraw consequence, success. Shit, man, why are these APIs so hard? Can deposit? I think honestly doing a transfer is going to be the easiest thing, actually. Just seeing the transfer. Let's do this. Let me see mutate real quick. Mutate. Born into transfer. Amount preservation is still a part of it. Okay, let's withdraw consequences found integer. So let's do let's just try this. So withdraw consequences consequence success. Consequence success. Let's see what happens. I need to import this item. Okay, success. Now let's see this fail. If I try to withdraw 100, or I try to withdraw 60, right? That's too much. It should be withdraw consequence. Let's see what the result is. Where is that item? It was from inspect. It should be balance low, maybe, or frozen, maybe is what I want, right? It's going to tell me that it's frozen. Pass. Oh, that passed. Okay, good. So, sorry, sometimes I need a sanity check. So success would fail. And success will tell you the error too, right? So this fails. Expected success, expected frozen, got success. So this is good. Frozen. And then it should be that if I set the freeze to 5,000, obviously, I can't even withdraw 1, right? Withdraw 1 will still be frozen. So again, if you have the mental image of the diagram, right, we have a freeze even bigger than the whole account. Okay? So let's in here, let's do a hold as well, right? So set hold, assert, okay, native balance, set hold, and I think it's probably the same thing, a hold ID. Let's look at the API. In here, there's a mutate hold, the reason, the who, the amount. So let's see what the reason is inside of mock. Hold reason is also the empty. So we're going to do set hold of this. The who is Alice, and the amount is going to be 50. So this should be okay. Set hold, not found in native balance. Set hold, not found. Do I have the... Huh? Ah. Terrible. Thank you. Okay, this works. So I can hold 50. I should not be able to call hold again on 60, right? She only has 100 balance. I've already held 50. I can't hold another 60, right? This thing telling me funds unavailable. So I can do that. So assert no op, hold Alice, token error, funds unavailable. Something like that, I think. Use SP runtime token error. Let's see that. use SP runtime token error. Bam. Okay? So this is telling me that. So here you see the freeze can be bigger. Here you see the hold can't be bigger. What was the other behaviors? Here you see freeze and hold can overlap each other, right? There's already a freeze for 1,000, but I can still put a hold, right? Obviously, with a hold of 50, if I try to do can withdraw, I don't know actually, but it might say, I'm not sure if it says frozen or held, right? That's an interesting question. Well, in this case, it'll say frozen because that's the big one, right? I mean, let me thaw. So thaw is removing the hold. Mutate freeze. I guess I can do set freeze to 0. Decrease frozen. Oh, thaw. There is thaw. You're right. There's thaw. So thaw will remove the whole thing. So in this case, after this stuff, I can do thaw, and thaw expects the ID and the person. So that should be okay. And then I can check can withdraw 1 should be success. And I can check that can withdraw of 60 will be I guess held. I don't know what we'll see what is what? Thaw. Thaw is a word about when ice melts, it thaws. That's it's an English word. And the answer is balance low. Balance low. So again, thaw is like we freeze them, and then thaw is like it melting. It's a Gav thing. But this all works. Okay? So you can see here that when we have a hold on the account of 50, we cannot withdraw 60. It's another error. So this is a bunch of things. Yeah, your question? Go ahead. Mm-hmm.
Yeah, Misha. So my question is on the freezing and holding, right? So all of them are on the like we're putting lock on the money, like we are reserving, right? We are like moving it from the free balance and then reserving it. But one thing
Kind
is,
of.
what is the significance of freezing and holding? Like freezing, holding, both two like have kind of similar mental model, but then they're
Right.
acting differently.
But I think we should do that in the presentation today, right? The presentation today, in this this palette the traits, the palettes and traits, I had these graphs, right? That held versus frozen, held balances they stack, frozen balances they accumulate, they overlap.
Yeah. So one thing is,
And I also talked about in here, I talked about maybe some examples, right? Here, held balances useful for deposits, frozen balances useful for like governance and staking. Okay, but what's your
for deposit, for storing data on chain, also your held balances stack on top of one another, useful for user deposits or similar. Okay, sure. I can. So okay, so in terms of like you can freeze the money and then holding it in terms of certain use case which needs user to kind of commit to it, right?
Yeah.
Okay.
So freezing it can overlap. So if you're building a voting system, you probably want users who can vote to also stake. So you have to use locks or the freezes, because freezes will allow you to stake and vote with the same tokens. But if you have something like a deposit, like for creating a multi-sig, you want to use a hold. You want to use a hold because a hold they stack, and you only want them to be able to create so many multi-sigs, right? There's a limit, the upper limit on what you want to do, right?
Okay. The first one you said, if you freeze, you can take the same. Yeah. If you freeze, you can stay. Let's say you froze 50, right? You can use that 50 in here and 50 in another place also.
Exactly.
The same amount.
The exact same amount.
Oh.
It looks like this. It is just looking that you know, that what you're freeze, it actually doesn't matter how much you can freeze, right? Like the freeze, it can be even more than you have, right? But freeze overlaps. It always is overlapping, right?
Okay, okay.
And, but
So it kind of reuses the past frozen money.
yeah, and like the freeze API will never fail. It will always add a freeze to your account. The hold API will fail. At some point, it won't let you hold more.
Okay, okay, got it. And also,
Push in the back.
okay, yeah. This question is not what you presented there. It's mostly on these two traits: negative imbalance and positive imbalance.
But you don't use them, so don't worry about them.
Yeah, I just need to understand them.
I mean, I can talk about them, but I just think that's like now's not the right time. Let's talk about it
Okay.
maybe on like a either one-on-one or like on a Friday where this is something that I just don't want to confuse more people.
Okay, sure.
And by the way, negative imbalance and positive imbalance, there's plenty of documentation and questions on Stack Exchange which answer those questions. Yeah. Okay, I don't know. I'll have to find it later. Okay, so here's some ideas. Okay, so we already did a bunch of ideas. That's pretty exciting. Let me commit this to my mini repo. So a bunch of changes here. So stuff did done. Okay. What was else my to do? My to do also had how to make types concrete, but I want to do help other people. So maybe basic identity, or maybe generating a unique account, showing how to store a call, the basics of free transactions. All of these things we're going to go over real quick. What is it? Okay. So actually, I left some of these things already in the code. So I'm gonna go into the code real quick for you. So yes, I will do that it's only a few minutes left. I'm gonna put the whole zip file up to Discord. Okay. Yeah. So I want to show the basics of free transaction. So I left for you in the free transaction palette a function called free transaction, where you can see here basically the main differences, the main changes. Notice that this is returning dispatch result with post info. We'll talk about this more later in this academy, but normally you do dispatch result. In this case, it's dispatch result with post info, and that allows you to return OK pays no. And that's the basic. This palette does that. And I think I wrote some notes here. What did I not write? Example of a dispatchable function that charges no fee if successful. If this line fails, the user ends up paying a fee. If this line tells the runtime to refund any fee taken, making the transaction free. So I think that your free transaction palette, this is the best, this is the most simple basis for making a free transaction. So you want to be able to use it like this. This obviously is not the correct way to do it, but like just having that dispatch result with post info, putting this pays no, and knowing that if they get to the end, they will pay no fee, that is the basis of which you can design system. Now, obviously, you need to include weights. So weights was an important part of this project. And for that, I have here some code for call weight. So I made a little code for you on how you can pass a call into a function, and then you can call this get dispatch info on the call, and it tells you the weight. Right? So if, for example, if you say this user has 1,000 weight available, and they want to make this call, you can call the weight here and compare, is the weight greater than what they have available? If not, you subtract, like it's basic math, right? Also here, I have a function called redispatch. Redispatch, the input is a call, and I just redispatch the call. So in a multi-sig, right, you maybe take in a call, maybe you store it, right? And then later you redispatch the call. And you can see here the weight of this call is using call get dispatch info weight. So the weight of this call is equal to the weight of the call coming in. Now obviously we'll talk about weights more in later in the academy, but I think this is the basis of ideas that could get you started with writing some code, okay? Any questions on this so far? And this is already provided to you in the README. So this is the basics of like, these are ideas, okay? this stuff here, this stuff here. And by the way, look at this. So obviously the call is coming as tconfig runtime call. We actually box this item so that the data is stored on the heap, because calls can be very big, right? A call could be a runtime upgrade, could contain like 4 megabytes of data. So we box it coming in here, right? But if you need to store it, then you need to actually store the real data. But just showing you some stuff here, okay? Yeah, it works. It compiles. Yeah, I think this function goes through the box. It works. This all compiles. Let's double check. Palette. This is free TX. Yeah, it compiles. So this is all working code. Okay, and then what was the other one? So okay, for that to do, so we did basics of free transaction, how to dispatch calls, right? Multisig, generating a unique account. So in multisig, I left for you this code, but I showed you earlier today better code. The better code was in the pure proxy. So pure proxy has better code. This is the basic idea. We can generate an account using some seed, some number, right? By basically making some entropy. So here I've made some entropy. I have some text, PBA, multisig, right? This is kind of unique to your palette. And then I have the seed, and then I hash it. I hash these two values together, right? So every seed will generate a brand new hash. And therefore, and then after I have the hash, I can then use scale to decode this, this value into an account ID. See, I'm returning an account ID. I'm decoding the bytes, and I'm doing this trailing 0 input. So trailing 0 input says, if the account ID needs more bytes, just add zeros. If it needs less bytes, it already will truncate the data, right? It will already truncate the number of bytes, right? And then I'm using a panic here, but it's a expect that in this case, you can always deserialize account ID, no matter how long it is, because trailing 0 inputs will just give me more zeros. There's no invalid bytes for account ID, right? Therefore, as long as I put trailing zeros, I should be able to decode something, right? So this expect will never fail. So this is a perfect use of a panic where I wrote expect and I wrote a QED, a proof of why it will never fail. This is good, okay? This is correct Rust. And so you have it. Now you could, if you wanted to, instead of doing expect, you could do option here, right? I think that's another thing, and then you have to go handle options the whole way, right? But this can be deterministic, so you don't need to do that. But this is a way that you could generate an account. And again, this does not take into account, for example, the block number or whatever else. This just is a seed. Now you could just do this, like you could just have a multisig where you have an incrementer and it increments the incrementer, and then you just use a new seed for each multisig. But probably not as secure or probably not as fancy, you know? But this is the basics.
If depending on the implementation of the account ID?
Can you say one more time?
Couldn't the code fail depending on the implementation of account ID?
You're saying that there could be an account ID which there's an invalid input?
Like the account ID just doesn't like the bytes you like. Like you could put in any account ID, right?
Yeah, I mean if there was a type, like again,
I'm saying like you can't just put expect because it depends on T account ID, right? You don't actually know unless you assume what the usage of a T account ID is.
I'm pretty sure. Okay, I kind of see what you're saying there. Yeah, maybe you're kind of right. I mean, yeah, okay, I understand what you're saying. That you're technically right, but in the context of the blockchains, right? Like the way that account IDs work, they're normally public keys, right? So.
Yeah, okay. Yeah, like in a practical sense,
okay,
of course.
How about this? I will not allow you to use this. If you do this project, you have to deal with the option.
I am doing this project.
If you're doing this, you specifically, you have to use option.
I just use the result.
No, I'm kidding. But I'm saying you're right. Honestly, you're right. You're right that I could imagine that with all the power generics in, this expects actually failing. Obviously, in my mind and for your projects, you have kind of a context in which you're building, and in this context, public keys, any valid bytes works. But truthfully, you could maybe do better code get rid of the expect, put an option. That should be, a little bit better-ish, right?
Yeah.
Okay. Yeah, you're not wrong. But this is the kind of place where I would expect to see an expect. And by the way, this exact line of code is in Substrate and Polkadot. It is there.
Yeah, I saw it in the multisig.
Yeah, it's there. Okay. So anyway, this is a basic example of how to generate an account. I also have in this the redispatch function because obviously when you're doing the multisig, you're probably going to have to handle dispatching calls. So there's a little bit of code there for you. Okay, so that's to do. Showing how to store a call. I didn't do that yet. Maybe we'll save that for tomorrow. Create a basic identity. I want to do that real quick. And then that will be it. And then DPOS has some code in there too. DPOS, let's look at DPOS real quick before I write one more piece of code. So DPOS has some helper functions here to help you with doing the staking stuff. So here I have a function force change authorities, which you can use, which passes in one person, but you could do more. It creates a bounded vec with that one person in it, pushes the one person, and then it calls palette aura change authorities there. So this is actually when you're done with with selecting who should be the new validators, you just call change authorities with a vector of the new validators, right? Okay. So this is working. This is compiling. This is correct. And then I have some other things here. A helper function to help you find the author of a block. So getting the author of a block is a little bit finicky. But here, if you want to know who authored a block, for example, if you want to reward them for making that block, you can use this function and then reward that user. You see there's a little bit of hackiness getting it in there. And you can set a test author. This is a test. Okay, so those are two functions that go in to help you. And these are mostly at the end of the process. So you don't need any special APIs to have people sign up as a validator or dominator or delegator. You don't have a lot of special functions to do delegation and manage all that. But at the very end, you select the validators, you push them to Aura, and then when they make blocks, you reward them by checking who the author is. Okay. So let's do the last thing, which is creating a basic identity in which one? In voting. So we already talked about why we need to do desibling in voting, right? That the quadratic voting system can be easily bypassed by a whale if they just split up their tokens to many accounts and then vote as small accounts. If you're designing a system and I find a flaw like this in your code, that points against you, right? Because it is easily attackable, your scenario. I'm not asking for you to solve the identity problem. That is still a problem ongoing. So what am I looking for you to show? I'm looking for you to acknowledge that this is a problem that you can't solve, but you have a basic solution for. So what I would want to see is something as simple as this. I would want to see palette storage, type registered accounts, t config equals storage map, sure, of underscore t account ID, and I can use the unit type. I don't have to put true or false. Should I do true? I do true or false. Okay, I'll do bool. We talked about why it could be more efficient not do it, right? Okay, but for the sake of this, okay. So first, let's make sure that compiles, because I'm doing that from memory, and that's never a good idea. Palette voting. Do I need a hash? Oh yeah, storage map. I do need a hasher. I need Blake 256. Blake 128 concat, dude. Doing this stuff, it just reminds you how crazy these APIs are. This so it's not Blake 2, it's Blake 2. Terrible. Okay, this compiles, I think. This is looking good. Okay, so this is registered accounts. And then I have a function called, let's copy some of this stuff here. Bam. Call index 2, register account, origin 4, who, t account ID, and I have ensure root origin, some higher authority, and I can do registered accounts t insert who true. Okay, let's compile. Okay, I have made a basic identity system.